So you say we get 1,000 applicable roles, right? Or the one that's left out, right? If I'm understanding correctly, do we ever go back and say, hey, we don't need this 1,000, we actually need this 100, or we use this 100 or that one? So that's actually what we end up
like a test set optimization time.
That's where we actually start using the thresholds and the filters. So we take that 1,000. How do we crunch it? We use simply represented as a percentage, like since the data sets were so low in like 30 relative to receiving, it's much easier to use like actual, there were 2 queries that like confidence is more the 2 well-known ones. But we ended up running into a lot of problems of almost like overzealous rule applications. So it's great that as we show right here, we're getting all these applications, so we're generating all these rules that can be applied, right? But are we just adding noise to the equation, or are we actually getting targeted enough? So confidence still turned out to be perfect filter, 1,000 down to 500, let's say. The split didn't seem to actually matter nearly as much as I would have expected. We have the dictionaries created, right? And basically all it gives us is a cumulative distribution function of frequencies that we can get calculated as well.
Right.
And say, okay, that's a really good indicator of how frequent is it. And if it's incredibly frequent, less valuable. And
kind of like stuff we're doing. Determiners all the time. It's not even
that's exactly if that was exactly the original one. Except for the side of the that's specific to the dictionary that you're using. So you're the dictionary created. So let's do this. And then the rule of two-ways filters is we went up to the dictionary terms, it goes to 5. But trust me, once we get out of 5, like that's where it starts going to a problem. There's a hardware issue there, or programming issue, but making rules more specific along these lines, they should be much more targeted to service and then again.
So good afternoon, everyone. So here we have now our fourth keynote speaker from the Ford Research and Innovation Center, David Ostrowski. He's a technical expert in data mining and machine learning, concentrating in the area of big data technology and social media analytics. He holds a doctorate in computer science from Wayne State University, and he has over 27 years of industry experience in software development within many areas, including real-time data analytics. He has 15 years of experience teaching CIS courses and at the undergrad and graduate level. He has over 40 referred publications, 2 book chapters, and numerous technical reports, and participate within the technical program committee, several journals. And so let us welcome David for this.
Hello. I don't know if I really need a microphone or not, but so I'll kind of keep the distance away from myself. Maybe if you want it to be louder than well. But wow, I'm really impressed. Local conference. I was just at the IEEE conference. I hold a workshop in International Conference on Semantic Computing a couple weeks ago in Anaheim, California, and I'm on the planning committee for 2017. Of course, my first inclination is to try to motivate a local conference here in Michigan. But given the fact that our temperatures compared to highs of 77 in California is proved to be quite challenging for me. So I'm very excited and honored to be here and to see a really nice turnout for this conference. My name is, as mentioned, Dave Ostrowski. I work at the Ford Motor Research and Advanced Engineering. I work in basically an analytics group, and my focus is on predictive analytics amongst a number of different areas. We affect all the areas. We act as internal consultants, and we affect all the areas of the company, from engineering to the Office of General Counsel, to marketing and sales, to customer service, dealer network. So we have projects coming out of our department, and so it really affect all the different areas of the company. And as you see, the title of my talk is a software development strategy for predictive analytics and big data. Of course, big data is the rage today, and a lot of our projects are entertaining these technologies, and that's what I wanted to talk about today. So, a brief overview of that. I wanted to get in what is big data. Everybody knows what big data is. I want to basically put it in context, the way I understand it, what it means to me. And along with that, just kind of make a brief overview of the big data technologies. I don't want to bore you with that, because I'm sure that anyone who's into big data is probably familiar with Hadoop and all that, the associated technologies. But just to put everything in context, and somewhat my philosophy, tempered by the experience that I've had recently working with it, as well as the projects that we handle and how we conduct our business at Ford. I have somewhat of an overall strategy, and then I want to talk about two projects that kind of fit into this space. I think everyone's tempted to turn their projects into a big data project. I've seen this too many times. I see, oh, turn big data, and I go to a particular talk or look up a particular paper, and when I find as a regular project that has been somewhat rebranded as big data, just to be invoked. I have a couple of projects that I want to explain, basically give an overview of what they are, how we want to leverage big data technologies, and why it's important. Because I don't want to do big data or use big data technologies just for the sake of doing it or being fashion. And along with that, really the core of my talk, I want to describe the overall strategy, which is putting the context of what I do, what I've started to do in the last couple of years with big data technologies, and how I feel that fits in the big picture, and where I think we should be going with technologies moving forward. To really taking a pragmatic standpoint and saying how we can leverage this and get a better return on investment. And then I have some conclusions with that. We're looking towards the future and some of the future technologies that are coming along the line with big data and what I'm anticipating. Because if you're embroiled in big data technologies as I am, Hadoop is really going away, right? That's so 2012, right? I mean, that is really viewed as old technology. So we have to look towards the future. And I think, from my perspective and the type of work that I'm involved with, how I'm leveraging it, and the constraints that I work within, I think that it's important to look towards these new technologies, because I'm really going to lead them. Because I think there's a lot of fallacies that big data is going to solve everything for everyone. It's not for every particular project. And I think that's the message that I want to convey in this talk. So what's big data? Okay, have these V's, all right. Gosh, I had to write them down to even remember them, okay. I'd have a hard time getting away from the presentation, talking about it, buying, writing. Someone came up with 5 V's. As I mentioned, I'm not too worried about some of these classical definitions of big data. To me, what it means is something that I can't run on a server. If I can run it on my PC, it's not big data. Okay? Doesn't mean that doesn't have the potential to be big data, or I'm working towards big data. But in my opinion, it isn't. So a lot of these V's and some of the terminology that has been brought up with a lot of the marketing around this, I think is I don't know. I think it's really overplayed a little bit. And as I mentioned before, what it isn't my own project that I desperately need to rebrand and make it fashionable. And a lot of times, exploring with these technologies, we are not at the truest level if you look at the most conservative description of big data technologies. It's really what the types of applications that you see with the Department of Defense or out in Silicon Valley, okay, with the .coms, okay, getting petabyte level. That, by every definition, is probably getting into big data technologies, definitely. Why? Because you cannot run it on a conventional server. I can't do an end-to-end application on this particular box, which I've implemented a lot of solutions for a lot of different customers within our business. And then it comes down to somewhat another point, is who cares, okay? And I kind of bring that up from the perspective that maybe I'm scaling up for big data technologies. Maybe I can do something faster than I could before. If something took 8 hours on my PC and it has the potential of overrunning my server in 2 years, maybe I should bite the bullet now and start exploring with the technologies and leveraging them as and understanding their best needs and understanding what their advantages and disadvantages are and what I need to come to terms with, so it isn't too late. Because again, what was the philosophy about doing big data in the first place? It's about having something. It's about taking on tasks that we haven't considered in the past. It's about rethinking how we solve problems and the types of problems that we want to answer. And I think these two projects kind of fit into that category. So I coined the term. I don't know if I'm the first one to bring this up or not, but I like the term small big data, okay? Because I think that's the realm that I work with, and I've seen some other people bring that up as well. And again, it's kind of borrowing from the last point that I brought up, looking at the data that's not, okay, really putting it in size, gigabytes, and terabyte level. But certainly not petabyte level. But having the potential of working in that direction. And again, I could run it on a big unit server, what I'm doing today, most of the activities. But as I implied before, perhaps more important than that absolute size is the intended size. If I have a project and I'm thinking that's going to scale up, or I would like to look at it in a larger scale, but I've had reservations in the past. Or even if it takes an inordinate amount of time to run it on a server, if I can get some immediate feedback, that can help my customer as well. We're doing analytics across the company. What has been the trend with analytics? Getting it in real time, getting it on mobile devices, getting it immediately to customers. They won't have to wait perhaps a day to get a particular report or some type of analysis. They can get it, some type of summary information on a mobile device, throw away their PC, then perhaps big data can suit that need as well. So it's around this theme of thinking outside of the box and perhaps outside of the server, thinking beyond that. And maybe I'm not there yet, which in some cases we aren't in the purest definition. And a lot of people have a lot of gray area in this space. And again, it's going back to the whole idea of considering taking on work that would normally not consider, or at least considering about perhaps redoing it into a space where I'm providing it at a lot faster rate of time, in real time, perhaps when it would have taken a lot longer to do that. So I already talked about, towards the projects that are appropriate for big data technologies. Again, it's towards that scalability. And some of the challenges that we have, again, is how do we scale it up? Okay? How about when we're going from small data, big data, going to really big data? And one of the things that I struggle with is a lot of vendors have rebranded existing tools. Okay, let's say a lot of your classical machine learning tools, open source, Clementine, a lot of the R libraries, for example, Python libraries. These have all been presented in the context, well, you can use this for big data. Okay. I find it interesting to note that that doesn't really fit the most conservative definition. Perhaps if you're taking the data and you're shrinking it down, and then you're going to be using those tools. But to me, perhaps on some level, that is not completely exploiting the parallel architecture that is presented on within the context of Hadoop and its associated technologies. So I struggle with these presentations, or what I see at the user level. I see vendors doing the same exact thing. They're taking the project, well, this is instead of being just a software tool, this is your big data software tool, which isn't the same tool. And some vendors have addressed that. Okay, you have like Revolution R. Okay, it's a particular vendor with R that's saying, hey, you can run our modules on a parallel framework and run this in the context of a parallel system. I see that as a very good compromise and something that is very appealing to me in the context of trying to take my work and fit it into this space and leverage it for whatever good that I can. Either again, projects that I couldn't handle before, maybe existing projects that are just that just do it faster, or do it really fast and perhaps put it in a different, present in a different context. We're presenting to the customer immediately, or I wouldn't be able to do that prior to it. And then there's also an issue of large-scale applications. Are they antiquated? Are they data operations? Should we take every single server and run it as a big data application? That is a tough question to ask. It's really about individual applications as you look at it. And you have to consider the question, can it be really operated in a parallel environment? So a lot of these issues are reflected in my philosophy and my approach. And it's about coming to terms with these big data technologies and what I can use them for. So here's kind of like the 2-minute overview. And again, I don't want to bore you with this, but figured I'd just make a quick run through it just to present it in the context. This is the classical, I hate using the term ecosystem, I like to call it the Hadoop suite, if you will, and I just put kind of pictures, illustrations over the what they would have, just some of the core components. Now, Amazon Web Service could be any commodity architecture. You have to use it as a test bed for some of my experiments offline that we use. We don't use Amazon and Ford, but that could be at Ford. It really exists as our any number of clusters that we're running the Hadoop technologies on that. Then you have the core technologies of Hadoop. And then you have the packages that run on top of that. Here you have, going from the left to right, I have Pig. And interestingly, Pig is obviously a complete language. So I do have functionality with user-defined functions. For instance, with Jython, and I can write in a complete programming language to solve applications. This is an interesting approach. I haven't really exploited UDFs in the context of Pig. Hive, okay, presenting the SQL capability on the data framework, poised to eclipse Pig due to the fact that you just have so many IT people that have been attracted to that type of technology. Spark, which I'll talk about a little bit more as we progress, is really independent of Hadoop. Here it resides on top of Hadoop, but it's in the context of really dealing with, the way I use it, is accessing just the file system that's supported in the core of Hadoop. But I have the arrow going straight through because Spark actually has its own scheduling capability and can run independent of it. This is, in my opinion, and I think most, is really our next generation big data technology. And on top of that, we have Sharp, which is going away, just replaced by what we term as Spark SQL. The Spark SQL and Scala Spark really provide a fantastic combination of Turing complete language SQL capability and a very object-oriented approach using a functional-based language that is very amenable to the MapReduce process. So that is really, cutting the chase. That's really, I think, our future forward overall. And I've been evangelizing through our channels to do development in that. But more important than that, I think it's what Scala on Spark provides is more of a simplistic approach to the MapReduce paradigm as it's applied to any of our business applications. And again, I think that the fact that it's a functional-based language, which Scala could be easily surpassed by technologies such as Apache Storm, that also has functional-based language. Just gave my let's get my memory at the moment, but using a variant of Lisp that also has similar type of capability, but obviously improved functionality around the means of applying functional-based language and applying in the context of parallel processing and supporting MapReduce. Then you have the other language support, which of course isn't as popular as Scala or Scala, however you might want to pronounce it. I know that the popular speakers refer to it as Scala, right? But they use the Scala was always defined as the language that scales. So that's why I have also going back to that. Then kind of rounding up the technologies, you have Mahout, which is actually a great first try, with regards to implementing machine learning in the context of big data frameworks. And then any other languages, with streaming and I/O. Me being a fan of taking that approach, I have used the approach of building, doing a lot of one-off experiments, ad hoc implementations, relying on the streaming and I/O library and Python programming language. And of course, there's Java that kind of exists as a system-level language in this technology. So I'm not going to repeat that. It's pretty much what I said. Looking at the Spark stack, as I mentioned before, you have a great combination here with Spark SQL in use in conjunction with Scala, due to the fact that everyone has a great familiarity with SQL to begin with. And then you have a lot of other great capabilities on the Spark platform as well. The streaming that you could use, streaming I/O, with the Spark streaming, being able to manage activities in real time. That is very attractive to me. I haven't gone end-to-end in a complete use case with that. But that again is very appealing to implementing, as I implied before, doing real-time analytics that is presented perhaps through mobile devices, that can be immediately processed and sent out to a user. So this is something that would be very hard to implement on just your basic Hadoop platform. Again, another motivation of going to the Spark Scala type of approach. Then you have MLive, which to me is an order of magnitude easier to use than Mahout, which is somewhat it's just not as easy to use, not as straightforward. Where MLive exists as a library that is immediately can be experimented with at the interpretive prompt, allowing for a lot of quick experimentation. Then you have GraphX, which supports Graph Library, which is very appealing towards one of my projects that I'm going to be talking about next. Though it doesn't have strong enough capability for what I'm interested in, and real strong support for Graphmetrics is the best that's out there right now. And I think it demonstrates more than anything just a lot of potential for the direction of this type of work. And then I'm not going to go into the engineering of this, right? We have the Spark core. I think the most important part of this is you have your own independent scheduler. So it really exists as an independent piece of technology from Hadoop. A lot of people almost consider the fact that it sits as I implied in the last diagram. No, I put the arrow going through it. That Spark doesn't really need Hadoop to exist. I use it on top of it in conjunction with Hadoop because of all of our files are residing in a HDFS representation. So everything I just said is pretty much in the overview here. So there's a lot of capabilities here that's represented in these newer platforms that, again, I think are very appealing. In particular with Spark, that they have a lot of support for different types of data types. Again, really accelerating the integration with existing applications. For example, Tableau, which is turned into a Ford standard. So anything that we can use that we can immediately roll in to existing applications or use with current approaches that we have in analytics, I think that demonstrate a lot of potential. So kind of fast forward through this. Let me talk about my projects. So the projects that not all the projects I'm working on or have been involved with, but the projects I feel have a lot of potential towards big data. The most important, the focus of a lot of my energy right now is a project that's newly been rebranded as a big data drive. You might have heard of, I think there's YouTube videos out on it. Definitely getting a lot of publicity. Mark Field made a reference to this at the Consumer Electronics Show, I believe 2 or 3 weeks ago in Las Vegas. What we're doing inside the laboratory is that we have a number of vehicles, employee-owned vehicles, of which we are pulling data through the canvas, all of the CAN information, and uploading it to the cloud, putting it to the data platform. And then the second project, now a little more detail in the next slide. The second project is really looking at social graph analysis. As I mentioned, I've spent a lot of time looking at social media, analytics, and again, I'm going to have to take those projects and put on big data because they are not big data projects. I'm not going to rebrand my projects to be big data. What I think is appealing is looking at social media from the perspective of graph analysis, looking at the social network. And I have performed experiments and demonstrated a lot of utility with regards to predictive analytics. They have demonstrated high correlation to marketing and sales, looking at graph structure and looking beyond volumes, because it's not an issue of volumes. So volumes may indicate something. People are tweeting a lot about a particular model or vehicle. Those do correlate on some level, but interestingly, the structure of the graph, or most importantly, how those messages are placed within the graph and how many connections and interactions that those people have with other people that they're interacting with. It's actually just a strong predictor, and interestingly, provide for a unique source of data. Trying to keep an eye on time. I was worried I was going to have enough material to talk about. No, I always do that. I was running over, so I try to keep an eye on the time here. But digging deeper a little bit into the big data drive, or what was originally known as connected vehicle analytics. This is a project that we have employee volunteers, me among them, okay, that our vehicles are collecting vehicle data and storing it on the Ford HPC Hadoop cluster. So we're taking all the data from around the clock, or when we drive the vehicles. It's being collected, and there's kind of following the graphic below here. Anytime you go to the dealer and they pull the code, so that's coming through the canvas. So here we have a download that we just plug in the OBD connector on the car, and they load that through the an Android device and send it to an Azure cloud interface, which we send to the Fort Hadoop, and then my work begins. We would start pulling down the data and seeing what we can do with it. So this is in support of mobility and developed in conjunction with the Ford IT research group. And this is around trying to see what we can pull out of the data, okay, amongst engineering, amongst looking at traffic congestion, answering any type of problems around warranty, driver behavior, and the list goes on. So there's a lot of different rich opportunities that are involved with this, and it provides for a unique test bed. The fact that it's not it's a very uncontrolled experiment. When people are driving around, you don't think that you're being monitored. You don't think about it after a while. And here we can do a lot of interesting studies, which I really can't go and present a lot of my data that's very specific. But among the questions that I have answered through big data is, are we reaching EPA standards, okay, in the driving? Those who are, those who aren't, what type of behaviors are they doing? Why aren't they achieving the EPA? Are they getting higher or lower? Or how are we driving our hybrids? Are we getting the same? Are we getting the expected fuel economy from them? And what is that result of? Are we driving them on longer trips or shorter trips? Okay, because that has a substantial effect on the fuel economy as well. And that's supported through, you can go online, they have it's been engineered by leveraging this OpenXE platform, which is an API that is available to the general public. So what we're loading up the cloud, you can actually take, and if you're a hobbyist, you can actually hook up your own Ford vehicle and collect this information and collect it on an individual level. The interesting part of the big data is starting to look at everyone, from somewhat of a collective intelligence standpoint, and look amongst consider behaviors amongst an entire group of people. So this slide is old, okay? We have well over 200, we have over about 500 vehicles now. And again, kind of getting back to the big data thing, is that we're at terabyte level with this project. And then compared to my contemporaries at Google or Yahoo, the Department of Defense, it's still not big data, okay? But it is definitely, we get to 1,000 vehicles by the end of the year. We go to 2,000, 5,000 vehicles. Yes, we will be at anyone's definition of big data. So definitely, this is a project that is going to leverage big data in any sense of the term. So that is, this was obviously, and this was chosen to be implemented on the Hadoop technology. The Hadoop technology really motivated that. So I think that this project, which I didn't initiate, really is being branded or presented as a big data project for all the right reasons. It's about thinking about, what can we do? What can we do that we weren't able to do before? And I thought that provided an interesting motivation. Second, the other project, bounce back to that, is that, again, with social media, I have looked at graphs that present very strong relationships, but I haven't really scaled them up. I've been using the R, in the past I've used the RSNA library social network analysis. And it runs slow when I try to look at, perform certain experiments. So this is a work that I've done on a large scale, but again, gravitating towards big data technologies and looking towards that. I think that this has a lot of potential of which I could scale this up and leverage that environment. Quick experience I make reference to in that some of the earlier work I've done a few years back in this round has been around support of Twitter. And again, not really looking at volumes. Of course, with vehicles, I do find correlations in volumes. But earlier, we didn't have even a strong significance presence in Twitter volumes, you know, even 4 or 5 years ago. So at that time, I considered mobile operating systems. People talking about their iPhone, people talking about BlackBerry. This is going back to BlackBerry days when they had significant market share. And interestingly, what I had found, this is just some, I got to put a graph of this, some of the samples here just because it looks interesting. Well, what I was able to find, kind of the chase, is that looking at graph metrics really presented a strong relationship to sales, or market, really not sales, but market share of those mobile operating systems. I have papers on this if you're interested in looking at this. And interestingly, the volumes didn't. Okay, and here I was looking at specifically centrality between this, and not just the static metric, but how they exist as a time series. So that to me presented a very interesting relationship. And how I formulated my graph was not by friends and followers. I looked at replies. Because I have a Twitter account, okay, I'm sure everyone else. I think I have 5 Twitter accounts. I haven't logged on any of them in about a year. So whoever I'm friending and who's ever been following me, okay, that edge in the graph is meaningless. And that's what I found out in a hurry as well when I was performing these experiments. What I did find out is that when I'm replying actively to your communication, whether it's a Facebook message or it's a Twitter, I've read your message. I do follow you, okay? So replies are a valuable representation of data. And more important than just the volumes, more important than someone tweeting about something is about someone who's tweeting to someone who's interested in that piece of information. And the metrics around that between the centrality and how that exists. But I don't want to get too off on that subject. This is very appealing to me. Back to my theme here. This is very appealing as a big data project because this I can see is not getting smaller; it's getting bigger. And, you know, over time, of course, the graph problem turns into an NP-complete type problem. So I see this as very attractive to running in a big data platform and saying, "Gee, back to the theme here. Here's a question I couldn't really answer to the fullest degree." And looking at it from a perspective that I wouldn't be able to. Because I just don't want to do it for its own sake. I really want to do what I think outside of worrying about how many V's I'm going to use to characterize big data. I want to be able to say, you know what, I couldn't answer this question before, and now I can because of this particular tool. Forget about 3 V's or 5 V's or whatever V's. I know there are 5 V's and an A and so on and so forth. Looking at everything that I presented to you technology-wise, what I like to think about, what I like to present it in is the context of one of my favorite all-time computer science authors that you would be familiar with, Lincoln S. Stein, who's going back historically was the creator of some great Chrome modules, and then writing a sequence of books. We had a book on Apache modules, and he presented all the web technologies in the first chapter of that book from the perspective of performance, simplicity, and power. And I like to think about everything that I do in the context of software development from that type of perspective. Everything's a trade-off, right? You have, if you wrote everything at a very low language, you would have a lot of power. Okay, you would have the fastest application. Correspondingly, it would take you a long time to do that. Okay, so a lot of that doesn't fit the environment. So what I did is I taken everything that I do in the context of my projects that I work in the context of big data, and I kind of put it along that representation. So working from left to right, I have the data flow. Okay, so I have my data sources. It could be either my projects, it could be the graphical representation, it could be the vehicle data. Okay? And it kind of goes through a number of steps. I think everyone as a big data developer and analytics does this. I reference first, the first column being first level analytics. It's really just like pulling down all the Twitter messages that I'm interested in, or pulling down a particular, all the fusions, okay, for a given month, so I can look at the vehicle data. Basically doing joins and basic filtering activities. Then beyond that, it's trying to look at something interesting, which you might reference as second level analytics. Okay, what kind of algorithms can I put around this data to make some type of designation, preferably do some type of machine learning from a predictive perspective. But before I do that, I have to I'm always going through some type of experiment, okay, to be able to drive some kind of utility from that. So that kind of fits down the second level analytics. And then beyond that, you have this presentation graphics. So I range the technologies between these three areas. Again, between either end of the scale, which the highest end we have high, a lot of power, okay, which would be translate power meaning what? Perhaps performance. Certainly more complexity goes along with that. And then at the other end is you would have higher ease of operation and obviously less power. Okay, so kind of working the way down, looking at the first level analytics. What do I have? I have scripting query languages. In this case, being Hive and Pig, and I guess that scale would actually, fit into that category as well. Actually, it in my opinion, really comes across as a very good solution. So it doesn't, here I'm presenting it more in the context of just basic new technologies. So moving forward from that, as I referenced with Pig, you do have extensions to the query languages. For instance, with Pig, you have the UDFs. Hive has been extended with a lot of proprietary type of support that allows you to do things that you can't do with standard SQL. And getting beyond that, of course, you can go into these frameworks on these open source projects that will kind of work in the context of streaming IO that have some type of framework that allows you to construct these solutions. And then working from that, it's really building your own framework or using the mapping streaming IO to use any computer language that you have to come up with a solution. This gives you a lot of power, okay? But compared to doing a query in Pig, it takes you a lot more time. Okay, it takes a lot more careful implementation. And finally, at the bottom, you have native language development. In this case, it would be doing pure Java, which obviously is going to take you a lot more time to develop than if you're working in the context of scripting language. So obviously, it's just less code. Okay, it's less of the code flow. Working across the second level analytics, from the bottom, I have the ETL graphical development type environment. Okay, you have, let's say, the WECA or Clementine framework. Very easy to use. It's easy to share information. It's not as powerful, not as flexibility, but you do have a lot of compromises here. You can using drill down scripting languages in many cases. You could use the API, for instance, with WECA. You could go drill down to Java, of course. That would bring you into some type of compromise between ETL graphical development and all the way down to bottom back to native language development. That's kind of bringing into what I would refer to as the business intelligence-based API, the APIs that might be behind the graphical development. Then again, kind of mapping the first level analytics, second level analytics are really at this level are pretty much exactly the same for the difference of what you're going to really be doing with your applications. So you have these parallel machine learning packages, let's say with Mahout. Okay, so you would be programming that, and you'd probably be writing some code around that besides using the API. Again, Scala is in my opinion, in experiments, it's really positioned very well in this area, giving a really good compromise with a lot of the existing popular machine learning approaches baked into scripting language. Then you have streaming I/O. Okay, so it kind of brings it to more of a custom solution. You know, again, working with streaming I/O, as I typically have been working, or in some cases, I refer to as designing streaming I/O solutions and just manually streaming HDFS files through them. Provides a strong compromise between doing a native language development, which really isn't necessary in almost all cases, at least like what I've been dealing with. And then again, going down to the native language development. So presentation graphics. You know, again, as I kind of struggle with this area because a lot of the packages here have been rebranded, and it kind of brings the issue. I know one vendor, I believe it was Hortonworks or Cloudera, it was Cloudera that came in and they said, well, we work at turning big data into small data, and that's how they fit into that final, the final touch, okay, the final representations. Maybe that doesn't have to be big data. I envision, at least at some point, that we're probably going to be interested in doing some type of parallelized operation to support the graphics activity. I think it would be a shame if it didn't address that. So all these technologies. So where do I really exist in this representation? Where do I want to go? Okay, right now, for first level analytics, I'm using the scripting query languages. I'm not writing custom routines to join my data. That's an obvious choice, and I'm fully leveraging the parallel framework in doing this. So there's no purpose, at least in what I'm trying to do, to look for any other alternative, even though perhaps something might be slightly faster. This works. It works well. There's no reason not to go anywhere else. And with regards to the extensions, query languages, I can just rely on. That really brings me to the next point of doing the second level analytics or some type of complete application. Along the second level analytics, I've been working with streaming I/O. Okay, in this case, using Python. It could be any scripting language for that matter. Really, I haven't even been using that. I've been doing more of a pseudo streaming I/O, just using programs that are designed as streaming I/O, not necessarily running them as streaming I/O programs. I know one thing, I'm keeping it in that format because once my information scales, it gets beyond ad hoc type of analysis, that I'm going to have that necessity of operating in a parallel environment. And if I didn't have that need, then there's no reason for me to do it that way in the first place. So I find this to be a very good space to be operating in, at least for the time being. It doesn't bring me to a very, very clean application to be delivered at the end of the day. That's why I find the Apache Spark and Scala to be a very, very attractive solution here, because it's forcing me, or it's allowing me to do a lot of one-off experiments, and yet put that into something that could be bundled and wrapped up into a jar file and built as a single application. And with a lot of functionality, including using persistence, I could, I don't have to worry about, let's say, rewriting information back to HDFS if it's too large, and running like a successive series of scripts. I could have one application and build it into a jar file and be done with it. And the graphics, I don't have any choices here. I'm working with what we have, okay, which is Tableau. Tableau is great, okay, but it's not, it doesn't operate well with extremely large data sets. I have to shrink my data down. So here, I think that the entire industry has a need here. You know, it's interesting, we had Tableau come into our department, and they're talking about, well, you know, what does everybody think? What can we do for you? And I said, well, I know what you could do for us. You could release your API. And that wasn't well received for whatever reason. I don't know if we're more of a marketing guy who didn't understand what I was talking about. But I think that's kind of a first step. If they did that, it would probably completely dominate the graphics market because they have a great end result. But what I think, and this is kind of pushes a little bit further down, not completely down to the level of parallels graphics, but it pushes you down just a little bit of getting to something that can be operated in perhaps in more of a parallel environment and controlled by it. I want to be able to control by a complete language. Okay? That I can build it completely into my application instead of just saying, well, this is, you know, I'm going to shrink around the data and then I'm going to hand it over to Tableau and I'm going to run my PC. Well, if I can run my PC, why am I doing it? You know, back to my argument we had before. So that's everything in the context, the way I look at it, and kind of where I'm operating within that. So where do I want to go? Okay, where do I want to work with this? We're still going through growing things at Ford. We're by no means have the big data thing completely nailed down. And we've done a lot of experiments. You know, they have a lot of your classical terminology, let's say data warehouse, and we have the Explorer, and then Farmer puts it into applications into something that is operate, you know, institutionalized, right? And we're still working towards trying to institutionalize a big data solution. I think most people are, and the people who say that who are outside of the DoD or .coms who feel that they have are probably just rebranding the old project. That's been my experience. But I think that, again, we want to use this approach, kind of push us further down the power, or find the best. We don't have to push all the way down because the tools that we have can operate pretty good in that space. I think it's about being able to support this whole collective approach to analyze my data and not worry about shrinking it down so fast, and I have to put it into a graphics package that's ultimately going to eliminate. So again, towards the direction, I think it's being able to affect things and affect them in real time. So moving forward, okay, again, it's about getting ready for what we really need big data, or even bigger data than what I have already. Okay, and this is involving, you know, MapReduce or any of these paradigms that exist in the parallel architecture that I want to completely leverage that. Because, you know, let's come to terms with the big data. Not everything is going to be able to be operated in parallel architecture. So I'm going to have to bounce in and out of that. And that's where technologies, you know, forward-looking technologies, let's say Apache Spark and Scala, using that scripting language in conjunction with these libraries, I can step through several MapReduce steps and have some gaps in between which I'm not doing MapReduce. Because looking at vehicle data, I'm looking at an individual vehicle. you're driving somewhere, you have to consider your action from end to end. It's considered as a sequential process that cannot be parallelized, only to a different degree. If I have 5,000 vehicles, I could take one vehicle and have that sequential process be done on one processor, one on another, and so forth. I can break it down that way. So I can look at creative ways. What's the whole idea around big data? It's about using all these technologies that abstract the process of taking a job and breaking it down like word count. Okay, but we don't live in the world of word count. Okay, that's not a real world. That's the whole world, right? That's a little sample problem. But I want to fit it where I can go off upon these other processors and accomplish these things that I wasn't able to do before. So that's really, the space that I want to move towards, and again, that's why I think that languages, the technology, let's say, as I presented with Apache Spark, would help accomplish that. So some of the challenges, outside of what I've already mentioned, it's interesting to note, along with these technologies is data integration. That is also a lot of potential big data. I really didn't mention either of these technologies. It's not either of these projects, rather. It's not just about collecting vehicle information, but it's the potential of merging it with geographical information, social media, weather information. Right? Back to my reference to the project itself. You're driving around and everyone's driving real slow on 96. Okay, what's going on? Okay, it's going to have a lot of significance to go and merge weather information like that, or the closing of I-96 as well. So these present a lot of interesting problems as well. And along with that, again, it's using it as an intended and coming to terms with the big data versus from the most conservative estimate, and looking at it from a perspective of maintenance. How do we want to maintain these applications and considering how they're going to grow? I'm concerned about losing something when we get to that final area of representation. If we're going to summarize everything to death, are we losing some of the message? Are we going to lose the ability to drill down? Okay. I think perhaps one of the strengths of some of the parallelized graphics types of interface, more of a research on, is that ability to find areas of interest, find significant patterns, and then immediately drill down to that area. Well, if I'm going to shrink, if I'm going to turn the big data into small data, then I have to go back and I have to repeat that cycle again. So that I think is lacking. That is really something that needs a lot of potential. Could have a lot of potential if it was supported in new iterations of this technology. So towards the status, so where I exist today, and I kind of made reference to this already. I'm using the joining and filtering, that first level analytics. I'm using MapReduce. I'm in the true sense of the word. I refer to pseudo MapReduce for my analysis, and because to me, I need to do experiments and I have to do rapid prototyping to support these test cases to be able to do proofs of concept. This has also been used at a predictive level. So right now we're more at a reporting level. We need to push it into really leverage the machine learning. I think if I'm not using, if I just want to break out data sets, I could have 20 servers that do this job. I think the strength of the big data technologies again is to be able to the most complete manifestation is to have to leverage collective intelligence. I think scale can help us. Okay? I think this helps allow for a faster transition that is empty complete that allows for a complete solution and has libraries that are going in the right direction. Other technologies, I'm not going to get into this a lot of detail. Hadoop, looking for a storm. What are these newer why do we need new projects, right? Well, you want something to do, right? You don't want to be bored. You don't want to be bored doing this stuff. More than that excuse, I think it's addressing some of the fallacies of big data today. That it's not easily applied to every particular project. And particularly my application, even with Twitter as a time series, and as well as vehicle data, which is sequentially collected and most importantly analyzed and cannot be doled out. I can't take a trip and dole it out to 10 processors of a particular vehicle and do it in a fraction of time. It's just not, can't easily be considered that way unless I do something completely sophisticated with message passing, which again would be pushing myself so far down that I never get my projects done. So again, it's about finding that space in between, which I think I'm finding with scripting languages, in particular the scale up and those associated libraries within the Smart platform. And Yarn, again, some of these newer technologies around. I see it somewhat of an admission that we need more flexibility in the scheduling. Everything doesn't fit into MapReduce in perfect fashion. More flexibility that we have around that, and more importantly, the more that we can abstract around that to support a rapid prototyping environment in this platform is really presents the largest potential. So that was kind of a brief overview of what I've involved with. In conclusion, I wondered, will visualization ever be in that parallel environment? And do we have to, or do we really have to come to terms with it? Maybe not. I think that's somewhat of an open-ended question. A lot of these classic machine learning tools, I feel embarrassed that we're still considering it in this environment. We like to be using everything with MLive or something that's really designed from the bottom up to be parallelized. I think it's going in the right direction, but I cringe when I hear about so much hype about tools that have existed for a long time already, and then they've immediately been rebranded because I want to be doing my predictive analytics in the parallel framework. I don't want to do it as an amplifier. I don't want to do it as a post-processing. Again, if I'm just going to do joins on a commodity parallelized architecture, I don't see a whole lot of difference between that and just having 20 old Unix servers or 2,000 or 5 million or whatever, or calling a balance on a web service and just instantiating 5,000 nodes and just running a Ruby script 2 million times. It doesn't seem to be buying me a lot. So I think that the direction of running predictive analytics, I think it should exist in that framework. And I think it's going to give us a lot more benefits in that area. And that really addresses the existing tools as well. So it's my talk. Thank you.
Yes. Actually, I have a couple of questions that I will share the room given time. So you're using Hadoop right now, and I know that there aren't a lot of challenges out there. You had mentioned one of them. And Microsoft seems to just not even, be acknowledging that the area exists. What kind of challenges are you seeing from Ford's perspective in gathering the data up? Do you specifically, it seems like a lot of big companies, take two approaches. One is collect everything because we don't know what we don't know, but that creates a whole other issue of mining. Or, we're going to target just these pieces of data because this is really what's going to help us get to our goal of what we're trying to, the question we're trying to answer. What approach, or both, or what's your philosophy on that?
My philosophy and my direct management's philosophy, then let's do everything. Let's integrate as much as we can. And I think that's definitely the way to go. I think one of the struggles that we've had with that is just a lot of logistics around it. You know, for instance, we have our CAN information is not decoded, okay? And that's unique information to each individual vehicle. So some of the struggles with leveraging that, right now I'm only utilizing a fraction of the existing data due to the fact that I have to go through a manual process of decoding, I have to track, and we don't have a centralized database for the CAN signals. So that is really a struggle. We're also working at trying to, we just recently brought in a consultant to do geographic systems and try to merge that data. But that's happening kind of after we pull it down from the cluster. So that kind of, we're doing what we can. I think that moving forward, kind of putting in the context of where I have my philosophies, I think that that's something that we should be doing as much on that parallel architecture as we can. Because if we have to, we shouldn't look at it as a repository alone. I think that we should, it should be a repository for the fact that it should be a single repository and put all of our collections of data and keep it always as close as possible. And I don't think that anyone disagrees with that. I think that from that perspective, I think that that's one of the things that we've gotten right. Figuring out what to do with it is where the challenge lies. You know, it is trying to, GM, it's interesting to note, GM has a constant data, so they have that infrastructure in every consumer vehicle. They have the potential, and interesting when people are talking to GM, they never have stored all that data. So they kind of had, well, on some level, they didn't say, well, let's store everything, and they didn't have the means of it because that was started about 5-6 years ago. So they couldn't maintain all that information in the centralized information. They just didn't have that infrastructure for it. So yeah, I think we're doing the right thing. I think the philosophy has been give me everything, and we'll figure out what to do with it. And we're somewhat still at a phase of trying to catch up with it. Another question?
And I will go first. Oh, no.
Okay, then we come. Okay, please.
You commented about the classic machine learning tools. So because of the large amount of data, it might not be useful. So what are the classic machine learning algorithms? So can you comment about their performance? The classic machine learning algorithms. So maybe how they perform in terms of the peak data. Maybe the algorithms that they have used.
Well, I haven't used them towards extreme large data sets. I think that I'm worried about it. I've done some low-level experiments, let's say clustering or Bayesian learning. But the problem is not just how they're going to perform now, or the fact, because I'm doing it offline, it's the fact of when my project grows, a year out in the future, 2 years out in the future, I think we're pushing the bottleneck. We're just pushing the bottleneck further down the road. We're not getting rid of the bottleneck, and I don't want to avoid. I want to be able to avoid that, and that's where that's where my current concerns lie. Is that I don't see enough happening fast enough in that area. Putting data up, a lot of data on the server today on a Hadoop cluster, it works great. I think it's very impressive what you can extract and pull down, and the response just happens pretty much immediately. You don't have to worry about jobs complete. But I'm concerned about do I have to shrink everything down? Okay, what if I want to consider larger data sets and scale it up? I think we're going to be going through a lot more activities in the future of summarizing our data, because it's simple. existing library, I think that our revolution, analytics, I think that they're pushing in the right direction instead of just rebranding. We use WEC in our group, we use SPS in our group. We're not going to be using it in terabytes. It's and again, I think that goes against the philosophy of doing it in the first place. If I have to shrink everything down, with one vendor, so we're going to turn to small data. I don't want a small data. I don't maybe at the very end of the pipeline, maybe I should be worrying about parallelized graphics. That was just following the same thing. But I don't think I'm too far off, and I want to push as much as I work at that I can, at least over the threshold, maybe not all the way down to writing everything in Scala or writing everything in Java. But I'd like to know that my libraries that I'm relying on are going to be industrial in strength, because otherwise I'm just doing a lot of first level analytics, and then I can tell my boss I'm doing big data, but I'm still doing the end analysis on my machine. And I think that is, I think that's contradictory to why we start doing it in the first place.
Thank you.
So one of the things that one of your slides had something really scary in it, which is kind of making real-time changes in the vehicle based on kind of information you learned. And one of the things that we have seen in the past day or so that we've been here is, people have been using, multi-objective optimizations in order to kind of generate, some things that can be used in decision making. But now you're talking or implying that, in the future, in your dreams, maybe, that you would like some of the things that you've learned be able to be used in real time in what is, I'm assuming, a safety critical part of the operation of the car. So how can you, because the other things that we've talked about, there's been a person in the middle that's used the information, made decisions, for testing purposes. You're talking about, data, machine learning in real time, or kind of making inferences from that, and then potentially injecting changes into the vehicle. So can you talk about that?
I don't see that happening as much with big data, and that's not our concern. I was just more in the context of like mobile analytics. We're giving this to decision makers, giving information around that. For instance, social media analysis. Let's say you're doing marketing support. You could find out, if you could analyze that graph in real time, and you could find out on a regular basis. Maybe you could generate different internet advertising based off of that. Just about rethinking about exactly what we're doing. No one's really been looking in the context, let's say, with the vehicle.
That's more the social side of it, what you would push to the drivers so they can.
I'm worried about the autonomous, the Google car more than big data analytics as it might be applied. I think that's going to be the biggest hurdle with regards to how autonomous vehicles in the future.
But as a follow-up to that, I think I recently read that someone had shown that if you played certain music on the car, that there would be it could kind of actually impact the driving of the car. Did you read about that?
No.
I can't remember all the details about it, but there's a certain symphony that they, now I recall, if they played this, they were able to show how they could attack the car and lock the doors of the car just by playing the music. So it's a little bit concerning pushing information out in real time. You don't quite know.
No, we're not looking at it from that perspective. I think we're trying to, types of questions that we're looking at, let's say back to the vehicle example, is that and this happens, okay, the guy comes out, he buys a hybrid, he's all happy, especially when he asks for $4. All the money, and we say, I want to drive this, and then they start driving around, and I believe the hybrids are really more amenable to getting those types of benefits in city driving as opposed to highway driving. It's somewhat contradictory. So they may be driving these patterns that they're familiar with, and they're not even getting close. This might be a tool on a higher level of figuring out, gee, why is this happening? So what can we do to help that person? Not necessarily in real time, but be able to answer these questions. Another engineering problem we're looking at is stop-start. So this is the technology that's been developed to support fuel economy. So you get so light, it'll stop your engine and immediately start it up before the light turns again, and saving you obviously fuel. The problem with that is that we don't know all the, you don't want it to be an irritant to the driver. You don't want them to notice. You want it to be seamless, a seamless transition. And they can't test that in the test cell because a lot of it's around driver behavior, how people are, where are they stopping, how long are they stopping for? Those are questions that our engineers don't know. So these are the types of situations that we can go back, or let's say with a warranty, let's say someone's having a problem with transmission. And sometimes we have reports that people have a problem with transmission, and 90% of the customers don't have a problem. So what's different with those people? What are they doing that is, that perhaps isn't anticipated or differentiated? And it doesn't necessarily, so it's not about solving that particular problem in real time or doing any type of, it's not Big Brother coming down and changing your vehicle. But all of that has to happen in real time to go to make a significant decision in a reasonable amount of time, because you got to consider the fact that it's about looking at everyone. Now, GM's better positioned to try to answer those questions in real time because they already have, this is a volunteer program internal. All their customers are already used to having all their data potentially being monitored by OnStar. So that core, my understanding is their struggles are the server, where they didn't have the means to store all this data. They didn't have the vision. That this was before the whole big data thing exploded. So they had that means, but they hadn't anticipated exactly what they're going to do.
The last question.
Thank you for your talk. You mentioned that you have experienced some performance issues when you're using capital software. And as long as I remember, it gives you the hand to do some query optimization, customization. So what exactly is
More my local machine. It's more just an issue around just speed of use, and it's not a particular an isolated problem, but it's just the fact that I noticed that it's not running as blindly fast. So again, a lot of these issues. And this is back to my other feelings about using conventional. Using what I've been using for the last 12 years, just towards the data that I pulled off of the server, is the fact of, well, I can get by, and don't get me wrong, I think Tableau is the best package out there, hands down. I've seen things done with that, you simply can't do it. I can't find an alternative for that. It's nothing against that. And any of the reservations I have, I could apply to insert any graphics package with that. So it's not personally against Tableau. It's the fact of what do I do? What am I going to do down the road? What am I going to do when I'm already operating in a space that is brand new, that we're going through growing pains. It's interesting to know. Last year, some of my joints were not running perfectly. So I was actually they're having some problems. I was talking to our Hadoop engineer in the cluster, and he says, "Wow, well you got a big file. This is 500 gig or something like that." I'm like, "No, it's not. This is not big. This is small. We have to reconsider. But it's about everyone working together and learning about how we're going to do what we have. More importantly, how am I going to manage 5 times the amount of data, 10 times, 20 times the amount of data potentially next year or the year following?" That's my biggest concern, because by then hopefully all the other pieces will be together. And I don't want to see any weak links because it's taken a while it's taken longer, I think, for everyone to realize, what the potential was. And now they're seeing that, but it's making sure that you have enough to get there, and you're not going to be spending an inordinate amount of time trying to develop solutions. Going back to the power and complexity type situation. If I got to drill down to lower level implementation, learning in Java, then I lose at that point too, because I can't clone myself, right? So I'm going to tend to need to go and like solutions. It's just more concerns than anything else. Right?
Okay, so let us set this speaker. We have a break of 30 minutes, then we have our last session.